Okay, in this presentation we're going to look at a continuous random variable question. So what we have here is the random variable x has probability density function f of x given by this expression here, f of x, there we have it there, equals k times x squared times 1 minus x. And our limits, which is to say where x exists on the number line, is 0 and 1. Okay, so what we have to do first off is show that k is equal to 12. So how do we do that? This is important to remember. The total area under the probability density function, when you sketch it out, and I have a sort of graph of it very shortly, between the upper and lower limits is, when you integrate it between the upper and lower limit, f of x dx, you should get equal, your answer is equal to 1 by definition. So what you can do is work backwards to find out what your number should be. So let's do that. So just going to scroll down here for a second, go down to the next page. There we go. So f of x equals kx squared times 1 minus x, where x is between 0 and 1. So the total area under the curve, there's our integral again, f of x dx. So when we substitute in our expression there, we have kx squared minus x cubed, k times x squared minus x cubed, and we simplify that, we get kx squared minus kx cubed. What we can do there, first off, is what we have here is essentially a definite integral. So let's take out the k for a moment and just work on the rest of it there. So when we integrate x squared, which we have here, what we would do there is we integrate that, we would get x cubed over 3. And when we have x to the power of 3, when we integrate that, we have x to the power of 4 over 4. So this is a definite integral evaluated between 0 and 1, as we're told in the question. So when we evaluate that expression for both 1 and 0 and subtract the difference, what we get is 1/3 minus 1/4, which is x cubed, 1 cubed over 3 minus 1 cubed over 4. We get 1/3 minus 1/4 minus 0 minus 0. So essentially that's sort of trivial. The zeros just essentially cancel out into nothing. So what we are left with there is 1/3 minus 1/4, which is equivalent to 4 over 12 minus 3 over 12. Now don't forget about k here. So what we have here is k times 4 over 12 minus 3 over 12. That is, let's just scroll down there. That is equal to k over 12, or k times 1 over 12. Now remember, k times 1 over 12 is the area under the curve, which is by definition what this should evaluate to. So necessarily k is equal to 12. So 12 over 12 will give you 1. So let's move on. That's the answer to the first part there. Now, so let's move on to the next part. Show that the mode of x is at x equal to 2/3 and draw a graph of f of x. So this is our probability density function there. Now I know doesn't come out great, but as well as I hoped, but so let's just sort of fill it in there a little bit. Okay, so this is the peak point here, and this is 1 down here, and this is 0 over here. Okay, you notice that it's slightly skewed, but also that the uppermost point is around here. Now you probably can't tell that this value here, that is 0.6 there, okay, and this is 0.8. So that looks like it's 2/3, but let's sort of prove it properly, okay? So where this part here in the number line, that is 2/3, okay, roughly, but let's sort of do it properly. So this is essentially what we're doing here is finding the maximum point of a curve. Okay, so this is using differentiation as opposed to integration. Okay, so what we have to do is differentiate our probability density function, and remember we're expressing k as 12 now. So what we have is 12x squared minus 12x cubed. What we do is we differentiate that with respect to x. Okay, and we get 24x minus 36x squared. So what we do there is we let that equal to 0. So the derivative where the derivative is 0, we either have a maximum or a minimum. So 24x minus 36x squared, when we divide that by 12x, which would equal to 0, but essentially what we do here is when we simplify that, we get 2 minus 3x equal to 0. Therefore, x is equal to 2/3. Now, it is actually correct to say that 12x is equal to 0, which means x is equal to 0, but that is clearly not the mode, which is to say it's not the maximum value of f of x. So the answer we're looking for is 2/3. Okay, so the other answers are not what we're looking for. Okay, the other solutions to the expression, when you let that equal to 0, they're not what we're looking for. Now, so to check that this is a maximum, which is to say the mode, what we can do there is consider the second derivative and check that it is less than 0 when at our point. So our point is 2/3. So we get the second derivative of this, or this is the derivative, the first derivative. So what we're going to do is differentiate that again, and we get 24 minus 72x, and clearly that is going to be very negative when at x is equal to 2/3. It's actually minus 24. So therefore, if the second derivative is 0 or less than 0, then we have a maximum. So they're fully sorted out, everything's sort of taken care of. It is the maximum, okay, which is to say it's the mode of the continuous random variable. So this is a big part we're about to start here now. Find the mean and variance of x. Now this is a very important expression down here, this part here, okay. E of x, which is the mean of x, the expectation of x, is the integral of x times f of x dx. Okay, so that's a very important expression. Now we're given the upper and lower limits in the question. We know that they're 0 and 1 because we're told that in the question. So f of x times f of x. Okay, so x times 12 x squared minus x cubed, and when you simplify that, or that expression there, you get, let's scroll up a bit, 12x cubed minus 12x to the power of 4. Let's just move the 12 out to the side there for a second. Okay, so x cubed, when we integrate that, we get x to the power of 4 over 4. When we have x to the power of 4, what we do is when we integrate that is x to the power of 5 over 5. It's a definite integral between 0 and 1. So when we evaluate it at 1, we get 1 quarter minus 1/5, 1 over 4 minus 1 over 5. When we evaluate it at 0, 0 minus 0, okay, so we can ignore that, okay. So just simplifying it out, and you can just sort of follow the arithmetic there. I've done it in very small steps. 1 quarter is also equal to 5 over 20, 1/5 is 4 over 20. The difference there is 1 over 20, 12 times 1 over 20 is 12 over 20, so the expected value, our mean there, is 3 over 5, okay, which is 0.6, not far off the mode. Just make a note of that, okay. So here we go. Now what we have to do now is find the variance, okay, the variance of x. But there's one step that we have to do in the meantime. We have to calculate the expected value of x squared. The expected value of x squared is actually done in a very similar way to the expected value of x, which is the mean. So we have the expected value of x squared here, and that is equal to x squared times f of x, the probability density function. So the only difference here between this and the mean is we're dealing with x squareds as opposed to x. But we can proceed the exact same way as we do before. The numbers will be slightly different, or the expression will be slightly different, but more or less the approach is almost the exact same. So x squared times our PDF, which is 12 times x squared minus x cubed. I probably could have simplified that a bit. I have already. But essentially what we do when we simplify that expression, we get 12x to the power of 4 minus 12x to the power of 5. And we're going to integrate that from 0 to 1. Now I'm going to take 12 out of it just to make things a little bit more easy to look at. So we have x to the power of 4 And when we integrate that, we have x to the power of 5 over 5. Similarly, we have x to the power of 5. When we integrate x to the power of 5, we have x to the power of 6 over 6. Straightforward integration. Okay, so essentially what we have here again is a definite integral. Evaluate this between 0 and 1. So x to the power of 5 over 5 minus x to the power of 6 over 6. Evaluate that at 1. We get 1 over 5 minus 1 over 6. When we evaluate at 0, we get 0 minus 0. I keep using evaluating at 0 because sometimes when you evaluate at 0, it doesn't cancel out. Just watch that. Okay? Always check that, if you get me. So 1 over 5 is 6 over 30. 1 over 6 is 5 over 30. The difference is 1 over 30. So our expected value of x squared is 12 over 30. And when I simplify that, that works out to be 2 over 5. Okay. So now what we're ready to do is get the variance of x. Okay. Now this is a very important expression here. The variance of x is equal to the expected value of x squared minus the expected value of x to be squared. Now just remember, these are two different numbers, okay? Two different expressions. They're not the same thing. This and this, two different things, okay? They just, watch the brackets there is what I'm saying. So we've just evaluated the expected value of x squared, which is 2 over 5. Previously, we evaluated the expected value of x, which is 3 over 5. What we're going to do is square that. And essentially, this is again a little bit of number crunching here. 10 over 25 minus 9 over 25. That gives us a variance of 1 over 25. Just as a remark, I didn't actually state it here, but the standard deviation of x is the square root of that, which should work out to be 1 over 5. Not that I'm checking, okay? So that is that part.